place value. The decimal point is the only place where you say the word and. So you have millions, 100,000s, 10,000s, thousands, hundred, tens, ones. There's no such thing as a oneth. And then you have tenths, hundredths, thousandths, and 10,000ths. The only time you say an and is right here. So if I have just made that up. This is 3,768,294 and 3,651 10,000ths. That's how you would say that. You hear people say 3,000,000,768. No. Commas aren't ands. Commas are just pauses. The only and is the decimal place. I know. Decimals are equivalent to fractions. Fractions and decimals are both pieces. And the same number of decimal places I have, 1, 2, 3, that's how many zeros I have in my denominator. So if I'm converting from fractions to decimals, or I'm sorry, decimals to fractions, I count the number of places, and then I put that same number over 10, 100, 1,000, 10,000, however many zeros it needs to have the same number of decimal places. And we read it as 197 and 215 thousandths. So 2 decimal places gives me 2 zeros, and then if possible you reduce it. We'll talk about that a little bit more when we get into the fraction section, but for right now the decimal places tell me how many zeros there are, because decimal places, if you looked, these are powers of 10. 10, 100, 1,000, 10,000. That's 10 times 10 times 10 times 10 times 10. You're just adding zeros every time when you multiply by 10. So it's the same idea. This is 36 hundredths, so 2 zeros. And then, like I said, then you'd want to reduce. The difference, though, is if it's a repeating decimal, that's not the same. And I'll talk about that in a few minutes.
And a repeating decimal is with the line.
Yeah, repeating decimal. This means 0.36, 36, 36, 36, 36, on and on and on forever.
So whatever number is
Under the line. Any number under the line repeats over and over and over until the end of eternity. And that we do differently, and we'll talk about that too when we get more to that. Okay. So to convert the fraction to a decimal, we're going to divide a numerator of the fraction by the denominator of a fraction. So the decimal bar this indicates division. That's the same thing as saying 3 divided by 5. As we move forward into further algebra, the further you go in math, we stop using this altogether.
And what do you make it?
Instead of using the division symbol, we use fraction bar to indicate division. So as you move forward in algebra, every time you look at this, you'll stop thinking of this necessarily as a fraction, because this could, I mean, this is 3 divided by 5, this is division. And fractions are decimals, they're equivalent, and so fractions and division are also equivalent. So this indicates division. I mean, it also means a fraction, but they're the same thing, really. Okay. So to convert a fraction to a decimal, 7 over 40 is the same thing as 40. So, well, 7 divided by 40, so 40 into 7. Well, 40 doesn't go into 7. So we put a decimal point, and we add a 0. 40 does go into 70 once, 40 times, well, to make it 40, and then I subtract. And that gives me 30. And I add another 0, which I bring down to give me 300. Now to guess how many times 40 goes into 300, I'm going to look at the 4 and I'm going to look at the 30. 4 will go into 37 times, which will give me 280. And I'm going to subtract, and that's going to give me 20, and I'm going to add another 0, which I'm going to bring down, which will give me 200, and 4 will go into 20 5 times, which will give me 200, and I have no remainder. So 7/40ths is the same thing as 0.175. These are equivalent, no problem. B, 3 goes into 2 no times, so I add my 0.0. 3 goes into 26 times, which is 18. And if I subtract that, I get 2, and I add a 0, and I bring it down, and I get 20. And 3 goes into 26 times, which is 18. And then I have a remainder of 2, so I add a 0. Do you guys see a problem yet? 18, 26, 18, 20. Yeah, it's going to go on forever and ever and ever, right? When this happens, that's when you get the repeating decimal. So 2/3 is going to be equivalent to 0.6 with a bar over it. That is the exact perfect answer. If you're asked to round, it is approximately, this is the symbol for approximately, 0.7. Because the 6 rounds this 6 up to a 7.
It's more than 5.
Right, because it's more than 5. So if we're rounding, we look at this to determine what happens to this. If this is 5 or more, we round up. If it's 4 or less, we keep it the same. And this symbol right here, you'll see that a lot. That means approximate. We're going to round to the hundredths place. Hundredths place is here. So we look at our 5. Guys, shh. So this rounds to 0.18 because a 5 rounds the 7 up. So what was the, let's see, was it 5 or more up the score? Oh my gosh, I can't remember the second half of it. For 5 or more up the score, 4 or less, let it rest. So that's, so here we're going to round to the thousandths place. Well, our thousandths place, we're not even showing our thousandths place right now. Do you see that? We have tenths and we have hundredths. So since this is a repeating decimal, we can rewrite it like this, which shows that the 5/4 is repeating 5/4, 5/4, 5/4, 5/4. That's a 5. Hold on, I'll make it prettier. Okay, we want to round to the thousandths place. That's right here. Tenths, hundredths, thousandths. So we look at this, which is a 4. On a 4, we're going to let it we're going to keep it the same, let it rest. So B is going to be 0.545. So here we're going to go backwards of what we just did, and the number of decimal places equals the number of zeros in the denominator. Okay. Terminating decimal, terminating just means it ends. You have terminating or repeating, or non-terminating, non-repeating. So terminating decimals end, like these, 0.06, 0.0023, 0.14. They just stop. Repeating decimals go on forever, and it can be one digit repeating, or two digits, or three digits, or several digits repeating over and over again in a pattern. And then you have what's called non-repeating, non-terminating, and those are numbers like pi. You guys have heard that pi has no pattern and it goes on forever. That would be considered non-terminating, non-repeating. Most decimals, though, are going to end or repeat. So to convert these terminating decimals or ending decimals to fractions, we want to count the number of decimal places. So I've got 1, 2, 3, 4. 4 places. And then I take this number. Well, these zeros out front don't really count as far as to write down the actual number in the numerator. So I'm just going to write down 23, because 0023 would just be 23 anyway. Does that make sense? Okay. And then I had 4 places, so I've got 1, 2, 3, 4 zeros. Now I need to determine if this will reduce or not. So (23) is an odd number, and 23 is prime. But if you didn't know that 23 is odd, 10,000 is even, so they will not both divide by 2. So, you know, all even numbers divide by 2. To determine if things divide by 3, do you guys know this trick? You add the digits. So 2 plus 3 is 5. 5 does not divide by 3, so 23 won't divide by 3. Neither will 10,000. To end in 0 or 5, you have to end in 0 or 5 to divide by 5. This won't work. To divide by 7, there's not really a rule, you just try it, but 23 does not divide by 7, 21 does. If it didn't divide by 2, it's not going to divide by 8. If it didn't divide by 3, it's not going to divide by 9. And if it didn't divide by 5, it's not going to divide by 10. So then you can try things like 11 and 13, but 23 is not going to, 22 is 11 times 2. So 13 is certainly not going to fit. So we're done. We can't reduce this. So that's it. That's your answer. Now if I have a whole number and a decimal, in the mixed number, this is the whole number part. And this becomes the fraction. So for B, I'll put 50. And then I have 2 decimal places, so that's 6 over 100, because I need 2 zeros. 2 decimal places, 2 zeros. Now 6 and 100 are both even, so I can divide those both by 2. So if I divide this by 2 and I divide this by 2, I'm going to get 50 and 3/50ths. And 3 does not go into 50. So I can't, because the only thing I can divide 3 by is 3, and 50 won't divide by 3, so now I'm done. With back and forth between percents and decimals. To go from a percent to a decimal, you move your decimal place 2 places to the left. You're moving away from the percent sign, so that's away from percent. And that's, if you think about it, you're moving away from percent. You want to go from a percent to a decimal, so you're moving away from the percent. And to remember 2 places, a percent sign has 2 zeros, right? So 1, 2, 2 decimal places. So if there is no decimal, it's right here, and I'm going to move it 1, 2 places. So I'm going to move it in front of the 7, 0.78. You can put a 0 there if you'd like. For 412%, I'm going to move 2 places away from the percent. So it's going to be 4.12. Here I'm moving 2 places, and then there's nothing in this second place, so I have to add a 0. So if there's nothing in the spot, you always add a 0. What did I just do? Sorry. So that's 0.00045. So empty spots get zeros. Darn it. Okay, so method 1 is to go from percent to decimal and then from decimal to fraction. Method 2 is to put the percent, whatever that number is, over top of 100. But then you have to simplify, because you cannot have decimals or fractions inside fractions. And you have to reduce. Okay. So 52%, this one would actually be an easy one to go straight from percent to fraction, because there are no decimals or fractions in it. So there's 2, like I said, there's 2 methods. I'm going to show you both. So for A, if I do method 1, is to go from percent to decimal and then to fraction. So we'll do that first. So 52%, I move this 2 places, and that becomes 0.52. Okay. And then to turn that into a fraction, I do 52 over 100. And then I reduce it. And that's going to be 26 over 50, because I divide them both by 2. But then I can divide by 2 again, because they're still even. So I get 13 over 25.
Making the percentage a fraction and then reduce them.
Okay, so I take this number, 52, and I always put it over 100. And then in this instance, I'm going to just reduce, which if you look with our method 1, we ended up with that exact same step, 52 over 100. So we get 13 over 25. It's when you get B and C that you might want to make a choice between the two. If you have a straight percent with no decimals and no fractions, just taking that number and sticking it over 100 is the easiest way to go. But when you have fractions and decimals inside your percent, you get to choose which method you think is easier to use. Okay, so I'm going to add another page here. And B was 33 1/3%.
Can you use the second method for that?
The second method first? Sure. I put that over 100. But I am not allowed to have fractions inside my fraction. This right here is illegal, because there's a fraction in a fraction, and we don't do fractions inside of fractions. So what I have to do is convert this to improper first. That's what I have to do to start. So I'll come over here and do that. 33 1/3. I multiply and then I add. I get 100/3. So far, so good? So then I'm going to come back over here. So I have 100/3 over 100. Yeah, it's still, well, I'm not done. But I have to have it as an improper fraction before I can do the next step. You can't do the next step with mixed numbers. Now, 100 thirds over 100 is still a fraction and a fraction, which is still illegal. So what I do is this is the same as 100 thirds divided by 100. This is the same, right? Because I said division and fractions were the same. So 100 thirds divided by 100, and if we had done the fraction section first, this would make more sense, but do you guys remember how to divide fractions by chance?
You have to change it to
You have to do the copy, dot flip, or keep, change, flip.
you gotta change it.
So it was keep, KCF, keep, change, flip. Keep, change, flip. So I do 100 thirds times 1 over 100. This is not right. That's right, sorry. Okay, so 100 thirds times 1 over 100. My hundreds will cancel each other out, and I get 1/3. That's method 2. Let's look at method 1, which is to convert it to a decimal first. Okay, 33 1/3%. To convert to a decimal, I first need to turn 1/3 into a decimal. So 3 goes into 1 3 times, which gives me a 9, which gives me a 1, and do you guys already see what's going to happen? It's going to repeat. So 33 1/3%, I'm sorry, I'm moving backwards, but this is the same thing as 33.3%. And if I move this over, isn't that 0.333333 forever and ever and ever? Because it's repeating. And didn't I just say that 1/3 was 0.3 repeating? So this equals 1/3. So 25 1/2%. 1/2 is 1 divided by 2. 2 goes into 1.0, 0.5 times. So 25.5% is the same as 25.5%. To turn that into a decimal, I move 2 places to the left. So this is the same thing as 0.255. I have 3 decimal places. So I'm going to put 255 over 1,000. These will both divide by 5. Um, 51 over 200, and 51 is prime. But if you didn't know that, again, I can add them together and I get 6, which means it will divide by 3, but 200 won't. It will not divide by 5. It will not divide by 10. It doesn't divide by 7, because 49, 7 times 7 is 49. Doesn't divide by 11, doesn't divide by 13. I could continue, but once you get to about halfway point, so about 25, 26, you don't have to keep going anymore. But I already know 51 is prime, so I'll stop. So we're done. This is my answer.
Get the answer quicker than.
Okay, so I'm going to go 25.5%, and that's going to be 25.5 over 100. It's always 100. And 25.5 is not allowed, So I'm going to convert 25 and a half. I'm going to just do it over here. Or sorry, 1/2. Yeah, no, wait. What am I doing? 25 and a half is 51 halves. So that is 51 halves over 100, which is still not allowed. So that's the same thing as 51 halves divided by 100, which is the same thing as 51 halves times 1 over 100, which is 51 over 200. So as methods though, you can still go from percent to fraction straight, or you can go from percent to decimal to fraction. So if we do method 1, which again is percent to decimal to fraction, I'm going to take that 6.5%. I'm going to move 2 places over, and that's going to give me 0.065, which has 3 decimal places. So that's going to give me 65 over 1,000, which will divide by 5. Which I knew because 65 ends in 5 and 1,000 ends in 0. 65 divided by 5 is 13, and that's 200, and 13 and 200 don't divide by anything, so I'm done. Method 2, from percent straight to fraction.
Yes.
Okay, 6.5%, I'm going to put 6.5 over 100. I'm not allowed to have decimals in my fraction. So if I have decimals in my fraction, what I have to do is I have to move this 1 decimal place over to get rid of the decimal. But if I do that to the top, I also have to do it to the bottom. Anything I do to the top of the fraction, I have to do to the bottom of the fraction, or it's no longer equal. So I get 65 over 1,000. I get the same thing this way. With the decimals in there, it's almost the same method 1 and method 2. So it's not as bad as with the fractions. And then again, they reduce by 5s to give me 13 over 200. So 2 places, 1, 2. So 0.92 is the same thing as 92%. 1, 2. 1,080%. 1, 2. 0.5%. Now, they didn't give us a good example of this, but I'm going to do it. Like, let's say I have 3.1. 1, 2, we have empty space again. Anytime you have an empty space, you put a 0 in there. So this would be 310%. Now, when you have whole numbers, you get over 100%. 100% is the same thing as 1. So if you're going to have a percent bigger than 100, that's because you had a whole number. That's just kind of a nice little check for yourself. Like here, 0.92, that was less than 1, so we're less than 100%. 10.8 is greater than 1, so we're over 100%. Just ways to check yourself. Guess what? There's 2 ways to do this. Okay, method 1 is to go from fraction to decimal to percent, and method 2 is using a proportion. Okay, it's up to you. So let's do A, and I'll start with method 1. So 2/5. To turn this into a decimal, I'm going to go 5 into 2, and that's 2.0. 5 goes into 20 4 times, so this is 0.4. To go from 0.4 to my percent, I will move 2 places, and this will give me 40%. Okay. Method 2 involves taking your fraction and setting it equal to x over 100, and x is going to be your percent. And it's always x over 100. And what we do is we take 2/5 is equal to x over 100. And then you're going to cross multiply. So I have 5 times x and 2 times 100. So I have 5x is equal to 200. And then you divide by the number on the x. So I divide by 5, divide by 5. 5 goes into 200 40 times. So my answer is 40%. Yes.
So it's basically easier when you're...
It goes into 20 6 times, which is 18, which is going to give me a 20, so I'm going to get 1.6 repeating. So that's 1.6666 forever. And I'm going to move my decimal 2 places. So I'm going to have 166.7%. And the reason I went with 0.7 is because this 6 would round up that 6 to a 7, and I don't like to write 3 6s in a row because I'm superstitious. I used to order extra, like, cinnamon twists at Taco Bell or something if my order came to $6.66. But like, throw some cinnamon twists in there. I'm not doing that. Okay, method 2, I'm going to take that 5/3 and I'm going to set it equal to x over 100. Cross multiply, and I get 3x equals 500. Divide by 3. X is going to equal 166.66666 forever and ever and ever, so 166.7%. And so if you needed to see, that would be 3 into 500, so that would be 1, 20, so that would be 6, 18, so that would be 6. You'd add the 0.0, so you get the 6. And you add another 0 and you get another 6. And then you'd round. We have Shauna having a raise. Her new salary is 105% of her old salary. So she got a 5% raise. Very nice. Of, this word right here means multiply. So what I'm going to do is I'm going to multiply her old salary times this percent. However, I can't multiply by percents. You have to multiply by a decimal. You cannot multiply by a percent. So first I need to convert this to a decimal. So I'm going to move 2 places over. So I have 36,000 times 1.05. And I cannot do that in my head. So her new salary is $37,800. Not bad. To find a percent, you take the part, you divide it by the whole, and you multiply it by 100. Or move the decimal 2 places. This is the technical formula, part divided by whole times 100, but it's the same thing as part divided by whole then move 2 places. Guys. So approximately 520 students from 3,500. This is the part. This is the whole. So I'm going to take 520 and I'm going to divide it by 3,500. Now, one nice little trick, zeros will cancel each other out because you're dividing by 10. So what I really have to do is divide 52 by 350, which you can divide that just exactly like it is if you want. I usually divide smaller numbers, but like I reduce them first, but it doesn't really matter. That's going to give me 0.14857. And there's a bunch of other stuff, right?
Okay, this last one. How much places are we expected to route?
Does anybody know how to say that?
Schenectady.
Oh, okay. See, it looks like Shinnencad-taddy. Yeah. Schenectady. Okay, good to know. All right, a natural number. Natural numbers are your counting numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc. If it is greater than 1 and it only has 2 factors, it is prime. So it can only divide by itself and 1. 1 is not considered to be prime because 1 only has 1 factor. So 1 really is the loneliest number because it's not prime and it's not composite. It's in its own little category all by itself. Poor thing. If it's not prime and it's not 1, it's composite. So you have all your prime numbers, you have all your composite numbers, which are most of the numbers, and then poor little 1 all by himself. Yes?
So what is 0?
Zero is zero is composite because 0 divides by everything. 0 divided by 20,000 is 0. 0 divided by 5 is 0. 0 divides by everything, but it cannot divide into anything. To write a number as its primes, we employ factor trees. 12 is 2 times 6, and 6 is 2 times 3, and when I can't divide anything else by anything, I take all the ends of all the roots of my factor tree and I multiply those together. So 12 is the same thing as 2 times 2 times 3. Or 2 squared, because 2 times 2 is 2 squared, times 3. 45 over 30. Both of those will divide by 5. And that gives me 9 over 6. And both of those will divide by, which gives me 3 over 2, which will not divide by anything in common, so I'm done. So if we want to, well, this one is relatively easy, actually. The greatest common factor between 14 and 42? If I divide this by 7, I get, which will both divide by 7 and 2 make 14, right? Okay. So if I divide, we'll do it in 2 steps. If I divide both of these by 7, I get 2 over 6, which will then divide by 2. So my greatest common factor would have actually been 14. But you get to the same answer. So I don't care if you do it in 1 step, or 2 steps, or 3 steps, or 5 steps, so long as you get there. No, there's not always, but sometimes. Okay, method 1 is to multiply, then reduce. Method 2 is to cross cancel, then multiply. So for A, 7/10 times 15/14. If I do method 1, I'm going to multiply straight across. So I'm going to do 7 times 15 and 10 times 14. Okay, I'll do the hard one. You guys do the easy one. Just kidding. 7 times, okay. But then I'm going to have to reduce this. They'll both divide by 5. And that gives me 21 over 28, which will both divide by 7. And that gives me 3 over 4. Now, I could have reduced first and then multiplied. And when you reduce first, you cross cancel. So 7 and 14 both divide by 7. And then 10 and 15 both divide by, I'm right saying 5. Then I multiply. Matter of preference. Get to the same place. So if this one would be a really nice one to cross cancel. B, these cancel each other out, right? 13 and 13 both divide by 13, and 2 divides by 2 as well as 2. So I have 1 times 1 over 1 times 1, so I have 1 over 1, which is 1. If I have a whole number, that's the same thing as a 5 over 1. Actually, there's 2 methods on this too. So I can do this, which these will cancel, and I get a 5. The other thing, when you multiply a whole number times a fraction, I like to write it this way. I divide. 5 goes into 5 one time. So this would be divided. And then this gets multiplied.
Well, when you get 1 for the first one.
Oops, sorry, not 5, 1. Yeah, you would get 1. Thank you. That was a 1. It's just writing too many 5s, and so I had 5s in my head. Here's another example of this method. If I said 10 times, not 10, 10's a bad example. (24) times 3/4. 4 goes into 24 6 times. We all agree? 6 times 3 is 18. Now, I would have gotten the same thing if I had put 24 over 1 and multiplied by 3/4. Because I would have canceled these maybe and gotten a 6, and then I would have gotten 18 over 1, which is 18. It just spares you having to write as much stuff. But either method works, you get to the same place. So pick, darn it. So 8/5 divided by 3/10 is going to be the same as 8/5 times 10/3. And I'm going to cross cancel on these just for sparing time. So I have 8 times 2, that's 16 over 3. Now the reciprocal of a whole number is 1 over that number. So this will be 12/13 times 1 over 6. 1 over 6. 1 over 6 times 1 over 6 is 1 over 6. 1 over 6 times 1 over 6 is 1 over 6. 1 over 6 times 1 over 6 is 1 over 6. 1 over 6 times 1 over 6 is 1 over 6. 1 over 6 times 1 over 6 is 1 over 6. 1 over 6 times 1 over 6 is 1 over 6. 1 over 6 times 1 over 6 is 1 over 6. 1 over 6 times 1 over 6 is 1 over 6. 1 over 6 times 1 over 6 is 1 over 6. 1 over 6 times 1 over 6 is 1 over 6. 1 over 6 times 1 over 6 is 1 over 6. 1 over 6 times 1 over 6 is 1 over 6. 1 over 6 times 1 over 6 is 1 over 6. 1 over 6 times 1 over 6 is 1 over 6. 1 over 6 times 1 over 6 is 1 over 6. 1 over Isn't math fun? So I get 2 over 13.